Welcome back to the next session. In the last session, you people have come across a cube resting on edge condition. In this session, let us know about the problem on tetrahedron. This tetrahedron is also one of the regular polyhedron. Means you can observe this. This is the tetrahedron, which have four faces. You can observe these four faces of triangular faces. You can observe these four faces. One base face will be there, and the remaining three faces which get bounded. This is about the tetrahedron. Now I will go for reading the problem. Condition they given, it is resting on one of its corners. It is resting on one of its corners. We have three corners present over here. If I keep the base part, whether it will going to rest on this corner or this corner or this corner. If I can name the corners A, B, C, it will going to rest on any of the corners, such that an edge containing that corner means resting corner edge is inclined to HP at 50 degree. Now for this is very important sentence, means an edge containing that corner is inclined to HP at 50 degree and VP at 30 degree. Means we know that it is resting on one of its corners. The resting corner edge should get inclined at an angle of 50 degree to HP and 30 degree to VP. This is the question about the tetrahedron. Now we should go for constructing the tetrahedron resting on one of its corner condition. In planes, you people have come across this triangular lamina. There you people know how to construct the equilateral triangle resting on edge condition and corner condition. Here they given purely on corner condition. Before that, I will go for drawing an XY line. I am drawing the XY line. Next I will go for VP by HP, vertical plane by horizontal plane. Now I am going to construct the tetrahedron by resting on corner condition. If I look at from the top view, the object will look like a triangle. First I will go for drawing the dimension of 55 mm dimension. I am drawing in a tetrahedron of length 55 mm. Next, with the help of the compass, I am going to measure the 55 mm length. From this corner, I am going to cut the arc. Again, from this corner, I am going to intersect this arc. 55 mm length edge I have written. Next, with the help of the compass, I am drawing the arc. Next, I will go for joining it. Okay, now after constructing the tetrahedron of length 55 mm, I will go for naming the corners. I will going to call these corners A, this as B and C. Now for the tetrahedron, we have the slant edges. These slant edges are from the top view, they are clearly visible for us. To get the slant edges, first I will go for drawing the, from B corner, I will draw in a thin projection line that should get meet to the opposite edge midpoint. I am drawing a line. Again from A corner to the opposite edge midpoint, I am drawing. Again from C point to the opposite edge midpoint, I am drawing. Now we will also going to get the axis over here and also the slant edges that are clearly visible. Now I am going to make the thin lines here. I am going to rub the connecting edges from the corners. I am rubbing those lines. Now from the top view, we can clearly visible all the slant edges clearly by knowing that I am making a thick line. Now I am going to call this point as O1. Now you can clearly observe here, from the top the base part is clearly visible and the slant edges are visible. I have drawn that. Next I should go for drawing the front view of the object. To draw the front view of the object, I will go for drawing the projection lines from the top view to the front view. One more projection line, again one more from the axis to get the front view of the object. Now in the problem they given that the tetrahedron of 55 millimeter sides of base. Now how to construct this front view of the object? Now by the appearance of the object to the observer, this slant edge will look like an inclined line to some angle. Again this slant edge is get inclined exactly what we are viewing from the front view. According to it, this slant edge is inclined, but this slant edge is inclined, but this slant edge will not be exactly at a length of 55 mm. But in the front view we can observe that this slant edge, if I project this slant edge, it is exactly at a length of 55 mm. For that, before going to construct the front view, I will go for extending this axis line to the required length. I am extending this axis line. Now from this B dash point, I am going to call this point as B dash, this point as A dash bracket C dash, this is my O1 dash. From B dash point at a length of 55 mm. Now if I project this, this is the slant edge length that will going to measure at an angle of 55 mm. From B dash point, I will going to cut an arc of length 55 mm to the axis line. Next I will go for joining from O dash to P dash. This is the length. If I measure it, it will be exactly an angle of 55 at a length of 55 mm. Now I will go for joining this A dash to O dash. Next I will go for to the base part. When it's come to the tetrahedron, don't get confused. Here they are not given the axis length, here they given the tetrahedron edges length. According to it, this slant edge length is going to measure in a length of 55 mm. Now I will go for the second position. Now this is the corner that I am going to call it as B point. This corner should get inclined at an angle of 50 degree to horizontal plane. Now I should rotate this corner to an angle of 50 degree. I am rotating it to an angle of 50 degree according to the question, because for this B corner, this is the connecting edge to the axis. According to the question, one of its corners it is resting, it is correct, such that an edge containing that corner, for this corner, this is the edge we are containing, is inclined to HB at 50 degree. Now I am keeping the object in the first position like this. In the second position, by keeping that corner on horizontal plane itself, I am rotating the object an angle of 50 degree. Now I am going to measure from B dash to O dash length of length 55 degree. We already know that. I am going to draw an inclined line at an angle of 50 degree. Angle of 50 degree. I am going to call this as B dash point and this point as O dash point. it will going to measure at an angle of 50 degree. Now I am going to measure it from B dash to A dash to get the base part. I am measuring from B. Now I will go for putting the arc B dash to A dash points. Again I will come to O dash point. I will measure from O dash to A dash. One more arc is intersecting it. Now I will go for joining it. This is O dash, this point is A dash bracket in C dash. Now I need to get the axis. I will measure from A dash to O1 dash. I will mark this here, A dash to O1 dash. I will go for the chain line. This is my O1 dash. This is about the second position of the object. First I kept the object like this. In the second position I tilted the object resting corner edge to an inclination of 50 degree. After that I have drawn the axis. Next I will go for drawing the projection lines from the top. Next I will go for drawing from B point. Next I will extend this to A point. This is C point, this is A point. Next I will go for drawing from the O dash point. This is O point. Now the projection lines, drawing the projection lines, I finished from the top views and front views. Drawing from the top view and front view. Next I will go for drawing the to identify the visible and invisible edges. According to the first concept is outermost edges are visible. C to A is one of the outermost edge. Again from C to O is one of the outermost edge. Again from O to A is one of the outermost edge. Outermost edge. Next I will go for applying the concept of the second concept, that is the faces and edges near to the observer is clearly visible. If I view the object from the top, O to A is nothing but O dash to A dash, O dash to C dash is clearly visible. According to it, O to C A means O dash to A dash, O to A, O dash to C dash, O to C, A dash to C dash, A to C is already visible for us. Next, the only corner that is connecting the slant edge from B dash to O dash is not visible for us. I will go for drawing the thin line, hidden line. Next, and one more thing is about this face, that is nothing but the resting corner and the B dash to A dash and to C dash. That face is not visible for us. I will go for drawing with the hidden lines. Next I will go for drawing the projection line from O1 dash point Now here the axis is present, I will go with the chain line. This is my O1 point. This is the second position top view of the object. Next, I'll go for the last position. They given that it is get inclined to VP at an angle of 30 degree. But here, one more thing we need to know about it. The resting corner edge is inclined at an angle of 50 degree in the second position. But if I measure the resting edge length in the first position, we have the length of 55 mm. But in the second position, the length of that resting edge corner is get diminished in the second position. You can clearly observe that this is of length 55 mm in the first position, but if I measure in the second position top view, I am getting around 37 mm or 36 mm. I am getting exactly 37 millimeter from O to B in the second position, because the object is get tilted in the second position. Now we know that if the true length of the given inclination edge is not same to draw the last position, we should go for identifying the beta angle. Now I will go for drawing the beta angle. For that, first I am going to draw the locus. I am drawing the locus line of given length, first length whatever they given, I will go for drawing an inclination of 30 degree for the given length. That is nothing but 55 mm. Next, I will going to draw one more locus here. I will come to the second position. I will measure this 37 millimeter over there. I will measure it. I am going to draw this line. If I measure this angle, this is exactly 51 degree for me. This is beta angle. We already know how to get the beta angle. In similar fashion, I have constructed it. Now I will go for constructing the object of given inclination for the apparent inclination. For that, I am going to draw a thin line of inclination 51 degree to the apparent inclination 51 degree. Next, I am going to measure this point as O point. Next, I will come to O to B length. I am going to mark that length from O to B till here. I am marking this. This is my B point. Next, I will go for making an hidden edge for it. We already constructed that in the second position. I am drawing the hidden lines. Next, I need other corners. I will measure from B to C or from B to A. I will measure from B to C. I am going to cut an arc towards to the upper side towards the axis, and one more arc towards the downward side. Next, I will come to O point. I will measure from O to C or from O to A. If I will going to cut an arc to this point and this point. Now this is my C point and this is my A point. Next, I will go for joining these lines. Our last position top view should be similar to the second position top view. I am joining these lines. Next, the axis representation is required for us. And similarly, I am going to measure it from B to O1. I am going to mark the axis here with the chain line. This is my O1 point. Now, I have transferred this second position to the last position. Next, I will go for drawing the projection line from all the corners. From C point, I am drawing the projection line. I am going to call this as C dash. Again from B point I am drawing the projection line. Again from A point I am drawing the projection line. This is my B dash point. Again from O point I am extending the projection line. I am connecting it. This is my O dash point. Again from the axis I am extending it. This is my O1 dash point. Next, the concept we need to apply for the visible and invisible concepts. According to it, the first condition is outermost boundary is clearly visible for us. I am starting from A dash point, A dash to C dash, C dash to B dash, again from B dash to O dash, from again to O dash to A dash is the outermost edge for me. Next, I will go for the second concept, that is nothing but from the front view to the observer, the faces and edges near to the observer is clearly visible. According to it, the base part, that is nothing but ABC is clearly visible for us. ABC is clearly visible. Already A dash to B dash, B dash to C dash, again from C dash to A dash is clearly visible for us. Next, O to A is already visible, O to A, O to B is already visible, and the only invisible edge that is not visible for us is nothing but O to C is far away from the observer. I will go for with the hidden lines, O to C. Next, I will go for drawing the axis. Okay, this is my last position of the object when it's come to the tetrahedron. In tetrahedron, the length they will going to give at a length of 55 mm. Don't get confused. 55 mm length construct in a equilateral triangle. Next, go for drawing the front view. While drawing the front view, first extend the axis, but according to the concept and according to the view of the object, this slant edge, if I project it, that is the only slant edge, the required length is available. After extending it, I am going to cut the R from the corner. Next, I am going to draw all the remaining edges. Next, I am incline that object to 50 degree by resting on corner itself. I draw on the top view. Again, the same thing in the last position. This is about the tetrahedron problem. Means similarly, they will going to give by changing the data, they will going to give the problems on tetrahedron and cube, and also on cone. The cone problem will be similar to the triangular problems, but they will going to ask the condition that it is resting on its one of its generators. Generator is nothing but the circular face, whatever it will going to present in the cone, but if according to the appearance of the object, when it's come to the cone, it will be circular face, conical face, but after drawing the 2D diagram, you will going to get it in the shape of the triangle. There the generators are nothing but the slant edges. In similar fashion, the object will going to appear. These are the generators. You should rest on one of its generators. That is nothing but you will going to just rest the object. Whatever the problems we have done in on slant edge and slant triangular faces, the problem will going to remain same for the cone. This is all about the tetrahedron problem.